Okay. Hi, everyone. Today I have the pleasure of introducing Sonny Stout, who is a senior at Allegheny College from New Jersey. He's an environmental science major and Arabic language minor who's been studying birds for 3 years with Dr. Jennifer Houts. The past 2 summers, he has conducted research on eastern bluebirds at Goddard State Park in Sandy Lake, PA. He has presented his research at two local conferences and two national biology conferences. After graduating this May, Sonny hopes to pursue a career in environmental outreach. Some fragments of this work were supported by PSO, and so we've invited him to give this presentation in part to close the loop on that research support. So thank you so much for being here, Sonny, and the floor is yours. Tell us the story, and thanks so much for being here.
Yeah, thanks so much for having me. Like you said, I've been doing this research with Bluebirds for the past 2 summers. This past summer's work was funded by PSO's student research grant. And this work has been on the effect of temperature extremes on blood glucose levels in eastern bluebirds. So to begin, climate change is causing temperatures to increase on average. So since 1973, we've seen an increase of upwards of 4 degrees Celsius of temperatures. On top of that, besides just warming temperatures, globally, we also see an increased prevalence of temperature extremes or climatic weather events, not just droughts or hurricanes, but also heat waves and cold snaps. I can say from my personal experience with PA weather recently, in the past 2 months, we've had nearly 80 degrees, and today it was snowing and hailing again. So those are the kind of temperature extremes that we're starting to see more and more often with climate change. Another effect of climate change is this unprecedented loss of avian biodiversity. So over the past 50 years, we have lost roughly 3.2 billion birds. And insectivorous birds, or birds that eat insects, are one of the key groups that are declining because of climate change. So how is climate change causing that decline? One of the first things that people associate with springs are birds. The temperatures start to get a little warmer, days start to get a little longer, and all of a sudden we start hearing birds sing. This is because birds use photoperiod, or day length, as their cue for when to begin courting and laying and hatching their young. So as those days get older, so begins the bird's reproductive cycle. However, insects, which are, again, insectivorous birds' food source, don't use day length. They use temperature cues. So as days get warmer, we start to see the insects emerge. This usually works out pretty well for birds. Usually as the days get longer, so too do the temperatures increase. And this means that birds' nestlings will hatch at peak insect emergence, so they have abundant food available. However, climate change is causing a shift. So we're getting warmer springs, we're getting springs warming earlier, which is causing insects to begin to emerge earlier. Climate change is not, however, changing day length, which means that while insects are emerging earlier, nestlings are still coming out at roughly the same time. So this is causing a mismatch where food is available earlier and nestlings that are born after that peak insect emergence face a lack of food availability, which can cause a decrease in reproductive success because of climate change. One way that birds are responding to this is through earlier hatching dates. So we can see in this study on tree swallows, which are a cavity nester, they lay their eggs in these nest boxes. Over the past 40 years since 1972, this study found that birds were nesting 3 days earlier per decade. So every 10 years, they were laying about 3 days earlier. And this is good because it means that they're matching up with their food source more with those insects. However, it does put their nestlings at an increased risk of early spring colds or cold snaps. Wild nestlings in particular face variable changes in not just temperature, but also, as earlier stated, food availability. So here we have a picture of a newly, freshly hatched eastern bluebird nestling. The 2 feathers on top of its head aren't even dry yet. That's how new it is. But you can see that, importantly, they hatch without any feathers, which means they hatch without any sort of insulation or protection from exterior temperatures. We also have this picture of a nest box in May, where we can see snow on the outside and presumably the interior as well. So for this bald little nestling, that's pretty stressful and pretty risky. On top of that, in the Northeast, we also see a positive correlation between temperatures and insect biomass, meaning that as temperatures get colder, there's also a decrease in food availability. So this nestling is facing stress from not only outside temperatures directly, but also because of how those outside temperatures are influencing its food availability. That food availability or insect biomass study was done using a Malaise trap. And I also used a Malaise trap these past 2 summers to look at, to assess food availability at my research sites. So how a Malaise trap works is insects will hit this black netting and they'll get trapped, try to escape by flying upwards into that white portion, where they are then funneled into that bottle, which has ethanol in them. So we can collect kind of masses of insects. I then went in and individually identified these insects to the order level, took these nice pictures. And this is part of a study to see how climate change, how these variable temperatures are affecting insect biomass across different regions. Getting back to it, I mentioned earlier that there's a study done on reproduction timing with tree swallows, which are cavity nesters. Cavity nesters are birds that lay their eggs in hollows, like a tree hollow, or in these nest boxes. Those natural tree hollows are becoming less common with deforestation as well as different forestry practices. And so nest boxes are a conservation tool to provide those habitats for cavity nesters. However, these nest boxes may be insufficient. Natural cavities provide more stable temperatures internally, as well as having cooler temperatures during peak external day temperatures and are typically warmer in the nighttime. Nest boxes, on the other hand, have very variable temperatures and tend to be warmer during peak day temperatures. This puts cavity nesters at an even worse position as climate change increases. Much of the research that has been done on cavity nesters has been done with tree swallows. So I wanted to look at the eastern bluebird, another common and charismatic cavity nesting species. Bluebirds lay eggs that hatch into altricial young. Altricial means that they hatch without any feathers. And as I mentioned earlier, that lack of feathers puts them at a greater risk of temperature extremes as they lack any sort of insulation. Studying cavity nesters is also often easier than studying birds that are open cup nesters, the kind of classic bird nest that we think of when we think of birds, because we know where they will nest every single year. We don't need to go into the woods searching for nests. These nest boxes will stay there year after year. Nest boxes are also easier to manipulate for scientific purposes. So in my case, I could manipulate the internal temperatures of these nest boxes. So how are temperature extremes influencing eastern bluebirds? First, I want to talk about the importance of glucose. Glucose is the primary energy source for metabolic processes and growth. This can be things like thermogenesis, or keeping oneself warm, as well as tissue growth, and importantly, body mass. So glucose fuels this body mass. And when we see an increase in body mass, we can therefore expect to see an increase in blood glucose levels. Glucose could be used to respond to these extreme temperatures that we've been seeing with climate change. Birds regulate their temperature through panting in hot weather and shivering in cold weather. Nestlings in particular are more at risk than adult birds, as they have less feathers as well as less body mass. Glucose, an increase in glucose could be used to respond to extreme temperatures, as it will power those thermoregulatory processes like panting and like shivering, which are pretty energy intensive. And body mass could be used, increased body mass could be used to kind of make the nestlings more sturdy against these temperature extremes. I hypothesize that extreme temperatures, so increases in either heat or decreases in temperature during the post-hatch or nestling phase, would result in an increase in body mass and blood glucose levels. I studied bluebirds at MK Goddard State Park in Sandy Lake, PA, which is Northwest PA. Goddard State Park was a really ideal setting because of where it is. It surrounds Lake Wilhelm. This kind of large body of water provides great habitat for insects. It's also surrounded by kind of prairie and farmland, which are also great habitats for insects. And so those combined make great habitat for bluebirds, which eat insects. Goddard State Park also has a nest box program where they have set up over 100 nest boxes across their trails. These have been set up by volunteers with the express purpose of boosting bluebird numbers. So we know there is a sustained bluebird population here. My goal was to simulate heat waves and cold snaps, those variable temperatures we see from climate change, using heat packs and ice packs. So for the heat treatment, as soon as the eggs of a particular nest hatched, I would add a heat pack under. For the cold treatment, I would add an ice pack that we kind of molded into shape and then slid under the nest. And then for my control, I put a heat pack that was spent, it was a couple days old, no longer producing heat. And this kind of controlled for nest height. You can see that it's been raised up, and also for disturbance because we were going to be going in there daily, switching out the packs to maintain temperatures. These treatments affected the nest box interior temperatures by around 3 degrees Celsius, or roughly 5 degrees Fahrenheit. And the treatments lasted from day 0, or when the nestlings first hatched, up until day 10, this is the period before the nestlings start getting feathers and when they are kind of barely feathered. So they don't have a lot of thermoregulatory processes, or they don't have a lot of insulation, and they don't really regulate their own temperature yet. Um, for my sample size, we had 8 nests for the cold treatment, 9 for the heat, and 10 for the control. Obviously, our treatments are not evenly distributed, and this was because bluebirds will nest in the same box for multiple clutches of eggs. So they'll raise multiple nestlings. And we want to have a different treatment for every successful nest. So after a heat treatment was successfully completed in one nest, we would then do a cold one. Some nests were also destroyed, or the nestlings died for unrelated reasons, possibly eaten. And so that kind of changed what kind of sample sizes we had. Like I said, this has been a 2-summer long research endeavor. My first year, 2024, we did that same temperature treatment, but during incubation. So on day 3, just to make sure that all the eggs had been laid, we would start the temperature treatment and continue it until the nestlings hatched. Whereas this summer, we started as soon as the nestlings hatched and ended on day 10. We looked at glucose using a glucometer, which is the same tool used to measure glucose in humans or people with diabetes. We would take a very, very small blood sample from the nestlings from their brachial vein, which you can see running across their wing there. Really just a small pinprick of blood to measure their glucose. We would also weigh them. We first weighed them on day 3, which you can see pictures of there, as well as on day 13, which is also when we took the blood sample. And this was so that we would have data for possible future experiments where we could track their growth over time. So this includes my data from the incubation treatment as well as post-hatch or the nestling stage. And I found that there was no effect from the temperature treatments on blood glucose. Not pictured here, we also looked at body mass and did not find that body mass was affected by the temperature treatments. One reason this could be is that instead of glucose, another energy source was being used in response to temperatures. So it may be that lipids or fats were changed by the temperature treatments. These lipids would fuel body mass, which is super important for nestlings. The larger their body mass, the more likely they are to fledge successfully or leave the nest box successfully. So if temperature changes were observed that affected body mass, it could then affect the fitness of birds in coming generations as climate change continues to increase temperatures and increase the prevalence of climactic weather events. For future directions or future studies, you could look at how molecular sex of the nestlings is affecting glucose or body mass. It could be that there was no effect on glucose or body mass when we looked at nestlings generally, but possibly male nestlings or female nestlings, which could be fed at different rates by the parents. That's been observed previously. It could have been that that was affecting my results, and looking at strictly male or strictly female nestlings would give a clearer picture. Um, Another future experiment could be to increase the temperature intensity. Like I said, we were affecting the temperature by around 3 degrees Celsius. These experiments lasted from March all the way to August. And if you think about it, adding an ice pack in, lowering the temperature by about 3 degrees during a peak July heat wave, um, putting an ice pack in there might not be an accurate representation of what a cold snap would actually be. So increasing those temperature changes could show us a more accurate effect of what these climactic weather events are doing to nestlings. We could also increase the amount of time spent with these temperature treatments. Like I said, we had 2 separate studies for incubation and post-hatch, or the nestling stage. It's possible that if this experiment had continued from incubation all the way to day 10 of the nestling stage, that there might have been an increase in, or more of an effect on glucose and body mass of the nestlings. I wanted to highlight how this research has kind of directed me in my path. I've really been pulled towards environmental and educational outreach because of this. I've gotten really excited about getting other people excited in birds and getting people to know about how climate change is so drastically affecting our natural world. One of the things that I've done is I've created these figures and some writing for a scientific research paper aimed at a young audience for Frontiers for Young Minds. I used what I learned in the field on how to take bluebird measurements, and also some of the pictures I took of myself taking bluebird measurements, to create this figure down here. And the goal of this paper was titled What is an Ornithologist? Was to get kids excited about ornithology as a possible career option, but also to let them know what ornithologists do and the different ways that ornithologists study birds. I also was a part of 2 different projects that focused on habitat for birds. The pictures of me in this garden were part of a National Wildlife Federation grant, where for my college campus, we wanted to improve habitat. I put about 10, maybe 15 nest boxes around campus. But we also changed grass lawns on campus into bird-friendly and pollinator-friendly gardens that would hopefully attract more birds and more pollinators to our campus. I was also part of the Adopt a Nest Box program last summer. So I installed 50 nest boxes for people around the college, as well as the greater surrounding area. I installed nest boxes on their properties for free to increase habitat. And I also did a couple different educational outreach events at the local library aimed at different audiences, but mostly young audiences, to kind of get them excited. This picture down here was where we had children draw on nest boxes. The nest box says, "The earth has music for those who listen," which I thought was very sweet. And it was really exciting to see the kids get excited about these habitats for birds. I also was a part of the Backyard Birds of Allegheny College coloring book. I created these 2 illustrations. This was also aimed at a young audience. We distributed these coloring books at the local schools and some of the outreach events I did to kind of get kids knowing about what birds are in their area and all the fun facts associated with those birds. finally, I created this art piece as a direct response to my research over the summer. I did not see that there is a direct effect on glucose from these temperature extremes. However, one thing that I did see while in the field was we would open up the nest boxes and we would see dead tree swallow adults. And it's likely that these adults would get too hot during summer heat waves, lose all their energy, and end up in the boxes and not be able to get out. Um, Kind of seeing that decrease in bird biodiversity that I talked about in the figure earlier directly was really impactful for me. And so I created this sculpture that I called Silent Spring, um, that is of a dead tree swallow to kind of talk about what we are risking with these loss of bird populations. This piece was shown in Allegheny Student Art Show this year. And then directly, my senior thesis was influenced by my research. I mentioned earlier that nest boxes do not provide the same insulation as natural cavities do, which puts cavity nesting birds at a real risk. So I wanted to look at how easy construction differences in nest boxes might influence their internal temperatures. So either painting them the outside white or changing the entrance type from a hole to a slot, how that might affect insulation of the nest boxes. So that's my senior project. And yeah, I wanted to again thank the Pennsylvania Society for Ornithology for funding for this research, as well as thank our collaborative professor, Dr. Sarah Canuti, and my advisor, Dr. Jennifer Houts, for this research.
Awesome. Thank you, Sunny. That
Thank you
was
so
really
much.
great. Having heard some of the prior descriptions of the general research project as pertain more to tree swallows and so on, like that whole part was fairly familiar, and the whole set of challenges around simulating real cold snaps and the sort of physiological tolerance, like with blood sugar, the body and the surrounding behavior's whole goal is to keep it in a desirable range. So you
Right.
can have the parents going, the extra mile to do everything possible to keep everything in the normal range, and physiological systems uptaking sugar and re-releasing sugar to keep it all in the desirable range. And so, like, you may not even see any signal until it's already too late or whatever. Like, you found dead birds, but you didn't find an effect on blood sugar.
Yeah.
Uh,
Yeah.
but the part that you ended with all of your outreach and work with kids, like I found that really inspiring. And I just feel so grateful to have people like you coming up thinking about how to solve problems about making better bird boxes for the heat waves of our future. Like it's coming, that
Yeah.
we're gonna have devastating big ones. And the more that we can be out ahead of these things and thinking about the challenges of the future, the better.
Yeah. Thank you so much.
People like you are what's going to make it happen. So that's awesome.
Thank you. Thank you. Yeah. I mean, it's hard because on the one hand, we want to kind of adapt to our future with climate change. But it's depressing to know how deeply it's affecting our world. Um, when I first saw that figure that was like 3.2 billion birds lost over 50 years, I mean, it's heartbreaking. Um, so really any solution that we can come up with to adapt to that, I think is really important.
Very much agreed. I'm also glad that Julia was here for your talk, because she's a science educator by profession as well, and a birder, and a good
Amazing.
person to network with. If you look
Yeah.
up Plummer, she's a she's a good person to chat with and be in touch with about educational materials and all that kind of work in life.
Yeah, no, I totally will.
Cool. All right. Well, thank you so much, Sonny. Appreciate
Yeah.
you presenting. I'll put this up on the PSO YouTube sometime in the coming week.
All right. Thank you so much. Yeah,
Okay.
thank you.
Good night.